Hey, welcome back. It's the review for Chapter 2 here. We're going to do a couple of problems that were asked. There weren't a lot. It looked like most of the comments were, I understand this, which is good. Hopefully that is the consensus across the board. But there were a few questions asked, so we'll talk about those. Let's start with 2.3. Number 10. Which says we have 3 times x plus 5 minus 10 is greater than 11. Or 2 times x plus 7 minus 15 is less than or equal to 5. Okay? So it's an OR conjunction of 2 inequalities. I'll just solve each of these individually, and then we'll deal with the OR at the end. To solve this one, I would distribute. So this gives me 3x plus 15 minus 10 is greater than 11. I can combine my like terms. 15 minus 10 gives me 5, so that's 3x plus 5 greater than 11. Subtracting 5 from both sides leaves me with 3x is greater than 6. And then I'll just divide each side by 3 here. That gives me x is greater than 2. Or the result of the other side. So I'll do that one. To distribute the 2, that gives me 2x plus 14. Minus 15 is less than or equal to 5. Combining my like terms here, 2x, that ends up being minus 1, is less than or equal to 5. Add 1 to both sides, and I have 2x is less than or equal to 6. And then if I divide each side by 2, x is less than or equal to 3. So I have that. X is greater than 2, or x is less than or equal to 3. I'm going to take this and put it up at the top so that I have a little bit more room to look at what's happening here. X is greater than 2. In fact, I'm just going to put them like this, and x, or, not and, x is less than or equal to 3. Okay. If I graph x is greater than 2, that's just a graph. There's a 2 somewhere on it. It's greater than, it's a strictly greater than, so it's an open circle and then shaded to the right. Those numbers. X is less than or equal to 3. Well, 3 is to the right of 2, so pick a spot to the right of 2 and call it 3. And it's less than or equal to, so since it includes that 3, it's shaded in the dot and shaded to the left. Now this is an OR conjunction, which means it's everything from this line plus everything from this line. Put those two things together, and you'll see that that's everything. Everything to the right is included in the top line. There's an intersection here of both, but then everything to the left is on the bottom line. So this is everything. That is all real numbers, which you can write like that, or in interval notation, it's negative infinity to infinity. It's everything. Right? Good. All right, let's look at 2.5. There's a question number 11. And that says 7 minus the absolute value of 3 minus x is less than 5. Okay. So as with any other absolute value inequality, I want to isolate the absolute value expression before I do anything else. So I'll subtract 7 from both sides. That gives me minus the absolute value of 3 minus x is less than negative 2. And it's tempting to see this negative on the right-hand side and say, oh, it's the absolute value in relation to a negative, but we're not done isolating the absolute value. So So we can't stop here. We always want to say, oh, stop. The less math I have to do, the better, but we're not quite there yet, right? I have to isolate this, so I'll do that by multiplying by -1. The negative cancels and just leaves me with the absolute value of 3 minus x. It also turns this symbol around, because we're multiplying or dividing, whichever way you view it, both sides by a negative, so my symbol switches. And then I have a positive 2 on the right hand side, and now I can break this into my two inequalities. And those two inequalities always have this expression unchanged, so it's going to have 3 minus x is greater than 2. It'll also have 3 minus x is less than -2. Right? And then, aside from being able to create these two inequalities, we also have to remember, is this an and or an or? And recall that if the magnitude of something is greater than some value, that means it's on the outside, it's further away from 0. That's a union of two different sets. That's an or. And so I have an or here. Now in order to work this, I'm going to take it up. So if you need any of this, write it down, pause it, because here it goes. I have 3 minus x is greater than 2, or 3 minus x, it's a funky looking 3, is less than -2. Okay. So that's what I have. Now each of these I'll just solve for x, right? I'll start by subtracting 3 on both sides here. That gives me -x on the left is greater than -3 and 2 is -1. Multiplying both sides by -1 means that I have to switch this symbol. So that is to say x is less than 1. Okay. On the other side here, I'll do the same thing, subtract 3 from both sides. That gives me -x is less than -5. And then again, the -1 gives me x, switch my symbol, so greater than 5. And again, this is an or. So if you draw out each of these, x is greater than less than 1 is, let's call this 1, and open at 1 and everything to the left. X is greater than 5. Please, when you do these, 5 is to the right of 1, so when you draw your second line, throw your 5 over to the right of 1. Don't come over here and say, well, 5 is wherever I feel like it being, because then it's weirdly not in the right spot for this other guy, right? So 5 is over here, it's an open, shaded to the right, right? This is an or, so I squish these two together and it's everything up to 1, so that is to say -infinity to 1, unioned with 5 to infinity. And there we have it. Good. Okay, and the last one that was asked was 2.6, number 10. So that one says, find the domain of this function. We have p of x equals 5 over, we have a square root, 7 minus 3x. So we have two domain issues here. The first I can see here is that we have a square root. So the square root, this tells us that 7 minus 3x, whatever's under that square root, is limited. It has to be greater than or equal to 0, because I can't take the square root of a negative number. And that's essentially what this is saying, right? I can take the square root of 0, I can take the square root of anything greater than 0, but I can't take the square root of anything negative or less than 0, right? So that's my first issue. The other issue is that this is all in the denominator. And therefore the 7 minus 3x can't be 0, otherwise I'm taking the square root of 0, which gives me a 0 in the denominator, and that's an issue, right? So I can take care of both of these simultaneously by eliminating the possibility of this being an equal. And it turns out to just be 7 minus 3x, and then has to be strictly greater than 0, and I just have to solve this, right? So I'll subtract 7 from both sides, leaving me with negative 3x is greater than negative 7. And if you divide each side by negative 3, this switches. Let me do it up here perhaps. We have this negative 3x is greater than negative 7. And if I divide each side by negative 3, that becomes x. The symbol switches. Negative divided by a negative is a positive, so that is a positive 7/3. And that's my final solution, is anything less than 7/3. So that is to say, anything from negative infinity up to 7/3, not including, so it's a parenthesis, not a bracket. Right? And that's our answer. Alright, good. Hopefully that was helpful. Get in there, do your assessment number 2, and we will move on to chapter 3. Thanks.